Let's solve a word problem using the law of cosines. And here's the word problem we're going to solve. A 50-foot vertical tower is located on a hill that makes a 5-degree angle with the horizontal. How long should two guy wires be if they are to be connected to the top of the tower and be anchored 80 feet uphill and downhill from the base of the tower? Well, first let's just draw a picture, figure out what this is even talking about. We have a tower. Let me draw the tower on a hill. Maybe I'll draw the hill first. So here's my hill. It's a little steeper than this 5-degree angle, but I'm just drawing it that way for emphasis. And we have a vertical tower, so the tower is going straight up. So I won't draw a fancy tower. That will represent my tower. And we're to find how long two guy wires should be if they're connected to the ground 80 feet uphill and downhill. So from here, we're going to go up 80 feet. And we're going to go down 80 feet. And the guy wires from the top of the tower down to the place where they're anchored to the ground are what we're trying to find. We're trying to find out how long those guy wires are. So there's one guy wire, and here's the other one. Clearly this one on the upper side will be shorter than this guy wire down here. Let's see, let's fill in what else we know. We know the vertical tower is 150 feet tall, so let's put in 150 right here. We also know that this is 80 feet, as is this, so let's label that as well. 80 feet, and this is 80 feet. Now our job is to find the length of this side. Let's just call it X. And similarly, in this triangle over here on the left, we're trying to find the length of that side, and we'll call that Y. We're just missing one piece of information that would allow us to find X. We need to find an angle in this triangle. If we knew this angle here, for example, we would know a side, an angle, and a side, and we'd be able to use the law of cosines to find X. And the key is going to come from the fact that the hill makes a 5-degree angle with the horizontal. We have a vertical tower right here. If we draw a line horizontally to it, that will give us some information that we need. So let me draw that. We'll draw this in a different color. This is the horizontal right here. Now, the word problem said that the hill makes a 5-degree angle with the horizontal. So that means this angle right here is 5 degrees. Well, if this is a right angle, and it should be, because we have a horizontal line and we have a vertical line, with this little angle right here being 5 degrees, that means the remaining angle, the remaining part of this angle should be 85 degrees. Right? I don't know if you can see it very well right here, but we have a 5-degree angle and an 85-degree angle that would add up to that 90 degrees. So now in this triangle, we have an 80-foot side, a 150-foot side, and an 85-degree angle. And while we're at it, since this is since this is 85 degrees, we know that this angle over here better be 95 degrees, because these two form this straight angle right here. So these two angles would have to add up to 180 degrees. So let's solve for X. Remember, we're going to use the law of cosines because we have the side, an angle, and a side. I'm going to remove the words from the word problem so we have space to do the work. So let me move that. So we have this side that we're looking for. So let's put that right here. X squared equals the sum of the squares of the other two sides. So it's 150 squared plus 80 squared minus twice the product of those two sides, 2 times 150 times 80, times the cosine of the angle in between them. So we have the cosine of 85 degrees. Now we can do some of the arithmetic here. This 150 squared plus 80 squared, if you grab a calculator and punch that in, you would find that it's 28,900 minus, similarly you could do a little arithmetic there and you'll find that that's 2,400, or excuse me, 24,000. I'm not sure what I said here. 28,900 and here 24,000 times the cosine of 85 degrees. And if we punch this into our calculator, we'll find that x squared equals approximately, right? Because we'll just get a decimal approximation for this. So we'll get approximately 26,808.26, and on it goes. It's an irrational number, so that decimal goes forever. So when we take the square root of both sides, and we know that's going to just be the positive value, we find that x is approximately 163.7, let's say 164. So this would be approximately 164 feet. Now, let me point out, I took an intermediate step from here to here by doing some arithmetic calculations. You have a scientific calculator, so you could go here directly just by punching in 150 squared plus 80 squared minus 2 times 150 times 80 times the cosine of 85 degrees. In fact, you could go straight from here to here if you punched it in with the square root of that entire quantity. But we now have the side of this triangle. Let's see if we can find y. We'll do it almost the same way, or in fact, exactly the same way. The only difference is the size of this included angle here. We still have a 150-foot side, an 80-foot side, and now a 95-degree angle. So let's see, do we have room down here to solve it? I think we do. So we'll have y squared equals 150 squared plus 80 squared minus 2 times 150 times 80 times the cosine of 95 degrees. We could punch that in. Excuse me. And we'll get 30,991.73. And when we take the square root of both sides, we find that y is approximately 176 feet. And as expected, this side was longer than this side. I hope this helps.